Hello, everyone. Welcome to our session on optimizing costs with Trino. I'm excited to share our journey of leveraging Trino to drive cost efficiency and improve business outcomes. Let's dive in and explore these strategies and best practices we have developed along the way. Our use case is analytics for internal users. So this include data scientists, data analysts, developers, sales teams, ad operations. So to talk about briefly, um, in today's fast-paced world, businesses are increasingly reliant on data to drive decision making, but the cost of maintaining high-performance data infrastructure can quickly spiral out of control. At Branch, we realized that our existing architecture was not only expensive, but also becoming unsustainable as data volumes grew for one of our business units. Faced with this rising operational costs, we made a bold decision to revamp our internal data analytics by adopting Trino and Iceberg. This transition allowed us to cut down on significant overhead, improve scalability, and still maintain a high level of performance, even faster than we initially expected. With a strategic trade-off of sacrificing some real-time capabilities for cost efficiency and slight latency in query performance, we gained a streamlined, robust infrastructure that continues to support our analytical needs without breaking the bank. Our journey of migrating from real-time analytics to Trino and Iceberg taught us that the right combination of tools can transform data analytics for one of our internal business units, offering the perfect balance between cost savings, performance, and scalability. We achieved a seven-figure savings with a few compromises. I'm going to explain in detail how we have done that in a bit. Let me show you the architecture of our real-time ingestion pipeline for querying. So this is the existing architecture which we replaced with the Trino and Iceberg. So we have an ingestion service which receives all events and then ingests them, publish them to Kafka, and then the backend processing reads those messages and enriches them, processes them, segregates them, and publishes into Kafka queue as different topics. Once these are published in the queue, our real-time ingestion service reads this information, aggregates that information, and store that information into our real-time database. The issue here is costs. We have seen that costs are increasing with the increase of data volume. As you are all aware, so the trend is somewhat looks like this. So as the volume is growing, the costs are also increasing. So we want to tackle this. So this is what we have done. So the challenge we had was soaring costs and scalability bottlenecks. Our previous architecture was built using real-time for our data warehouse, which had served us very well for some time. However, as data volumes grew, operational and infrastructure costs skyrocketed. Despite the query engine's ability to deliver sub-second query performance on real-time data, the price tag associated with maintaining the speed and scale became unsustainable for us. We were spending significant amounts on the following items. The first one is the high infrastructure costs for scaling real-time data clusters, maintaining complex ingestion pipelines for real-time data, additional compute and storage resources to maintain the required query performance. Faced with this challenge, we began exploring alternatives that could provide a similar experience in terms of querying and processing, but at a lower cost. That's when we decided to look into Trino and Iceberg as potential replacement. It's not easy to switch from an existing architecture and existing system to a different one. As you are all aware, as data engineers, you might have experienced this. Though it's challenging for us, but to save costs, we have decided to take a pivot and then, experience it. So that's what we have done. So the decision to move from real-time query engine to Trino and Apache Iceberg setup came after evaluating multiple modern data processing and storage solutions. Trino, as you're all aware, a fast distributed SQL query engine, gave us the flexibility to query data across disparate sources. Iceberg, a table format for large analytical datasets, enabled us to manage large datasets efficiently in our data lake. Then you might have questioned us like, why Trino and Iceberg? Why not others? We have explored all options available for us, out of which we chose Trino. Why? The major driver behind it is the cost efficiency. Trino, Iceberg are open source solutions, and their integration with our existing cloud infrastructure allowed us to significantly reduce our operational overhead. And then flexibility in query. Trino, as you're all aware, provides a SQL query engine that works across multiple data sources, making it ideal for our analytical queries. Iceberg's efficient data layout. Iceberg is designed to handle large data sets with minimal overhead, providing better performance for incremental processing and optimizing large-scale data processing. Reduced compute requirements. Unlike our previous tool, Trino does not require constant scaling of clusters to handle the growing data volumes, thus further reducing cloud compute costs. By adopting this combination, we had no need to maintain expensive clusters just for real-time querying, which became a major driver in cost reduction for us. So here is the architecture for the Trino Iceberg system. So since you are all aware, Branch is a mobile company. So we have so many devices in the wild which sends us the events. So our ingestion service receives those events and then publishes them to Kafka queue. And the backend processing jobs read the Kafka data and then enriches them, segregates them, and then publishes to different topics in Kafka. Now, that's where the change has occurred. Until now, you have seen before. From here, what we have done is, instead of going for the real-time ingestion, we have switched to batch processing, and this batch processing allowed us to store data directly in Iceberg. And once data is in the Iceberg, then we have used Trino to query it and present data to our internal users. So we use several BI tools to access data with the help of Trino. How we have implemented this? So what kind of technical adjustments and trade-offs we did? So the major thing we have done is the sacrificing real-time performance for cost savings. One of the key trade-offs we made was accepting a slight lag in the data freshness. Our near real-time query capabilities were crucial for some use cases, but for our internal data warehouse, it wasn't a critical factor. Trino, combined with Iceberg, could still deliver very fast query results, although not real-time and with some query latency, but at a fraction of the cost. We introduced a slight delay in data ingestion, which allowed for more efficient batch processing in our pipeline. This slight increase in lag proved to be worth it, as It allowed us to cut down the need for real-time infrastructure, saving us nearly a seven-figure per year. While we initially expected slower query response times compared to our previous setup, but Trino surprised us with its speed. Queries on historical data were returning results much faster than anticipated, thanks to Iceberg's intelligent partitioning and Trino's distributed query execution capabilities. So we couldn't thank enough that we were able to almost achieve the similar query performance, not exactly the same, with some lag, but we were able to do it. It improved query performance for us. Even with billions of rows, Trino's ability to push down complex queries to Iceberg's optimized data format resulted in consistently fast response times. Reduced maintenance effort. The Trino Iceberg setup required much less tuning and management compared to the other tools' ingestion and indexing processes, further cutting down operational complexity for us. All in all, what happened was once we have implemented this, we have realized unexpected performance gains coming out of this setup. Although the initial goal was purely cost driven, we were pleasantly surprised by the performance of the new system. Trino, working with Iceberg, was much faster than we had anticipated for our use cases, especially for analytical queries over historical data. This led to additional benefits that were initially unexpected. So some of them I'm listing here for you. Better query optimization. Trino's cost-based query optimizer worked well with Iceberg's efficient table structure, leading to significant performance improvements. Support for large-scale datasets. Iceberg allowed us to scale our datasets to petabyte scale without worrying about performance degradation, something that became increasingly difficult with other tools. Unified access to multiple data sources. As you're all aware, Trino's flexibility allowed us to query not only our Iceberg tables, but also other data sources like relational databases and object stores, all from a single platform. Here are the results. By transitioning to Trino and Iceberg, we achieved our primary goal of saving few $100,000 per year. Beyond just the cost savings, the move opened up opportunities for us. So some of them here I'm listing for you. Scalable infrastructure. Trino's ability to handle large-scale data processing means we were well prepared for future growth without proportional increase in costs. And simplified data management. Iceberg's support for asset transactions and schema evolution simplified how we manage data at scale. Adopting modern data lakes. The flexibility of Iceberg allows us to experiment with modern data lake architectures, giving us the ability to integrate newer technologies as we expect. All in all, with this experiment, with the change of setup, we have learned some of the important lessons. So I would like to share that information with you all. So the first one is cost versus performance trade-off. We learned that significantly sacrificing real-time performance for batch processing led to cost savings, especially for our internal use cases. It may not be suitable for everyone, but for our use case, we have petabytes of data which needs to be analyzed by our data scientists and developers, salespeople. So we have decided to take this route, change it to batch, and then changed it to Iceberg, and we are querying with Trino. So that's how we were able to save all the real-time spending we were doing earlier. Open source solutions are competitive. Our experience showed that open source tools like Trino and Iceberg can outperform traditional commercial solutions at fraction of the cost. As my statement says, it may not be true all the time for all use cases, but for our use case, it worked very well. Optimizing for growth. Our new infrastructure is designed to scale, making us confident that we can handle increasing data volumes without exponentially rising costs. In the future, we plan to explore further optimizations in our data pipelines by leveraging additional features of Iceberg, such as time travel and metadata management. We are also considering the integration of machine learning models within our Trino query engine to derive insights directly from the warehouse. Here is the conclusion: a successful transformation. Transitioning from our previous tool to Trino Iceberg was not just a cost saving decision, but a move that redefined how we approach our data architecture. We were able to balance cost efficiency with performance, allowing us to deliver actionable insights at a significantly reduced operational cost. This success story is proof that with the right tools and a willingness to make strategic trade-offs, businesses can optimize their data infrastructure without sacrificing performance. And in our case, even exceeded our expectations. Thank you all for joining me on this journey to optimize costs with Trino. I hope you have gained valuable insights and takeaways. Let's continue the conversation and explore how we can apply these strategies to drive business outcomes.